Hey guys, what is going on? Welcome to another Pygame tutorial video. In this video what we're going to be talking about is how can we actually put something on the screen and draw to the screen. So there's actually quite a few ways that we can put things on the screen, but there's really two main ways. The first is going to be using like sprites, which is where we take an image and we kind of put it on our surface. And by image I mean something that we've created maybe in Photoshop or something like that, and then we load it into Pygame. But there's another way built into Pygame that we can draw to the screen, and that's quite literally just drawing using Pygame. So we can draw various shapes, like polygons and squares and circles and this kind of stuff. And you can draw lines, and to do it we use coordinates. So that's what we're going to be doing in this video. Is I'm going to show you guys really actually two ways that you can draw to screen and what the difference between those two ways of drawing to the screen are, and how to get that to update to the screen. So with that, let's go ahead and get started. So this is our code at the moment. It's very simple code. It just runs, and when we exit, it's going to quit the game. The first thing that we need to do is we don't need this first update, so I'm going to go ahead and just delete that, 'cause we don't really need that. Now, probably one of the most popular things that you're going to see at the top of people's scripts. Obviously, you're going to see this bare bones stuff that I was telling you guys about, but you're going to quickly see after pygame.init, or even maybe above it, you're going to see somewhere that people are defining their colors. For whatever reason, I wish that Pygame had at least, you know, red, orange, yellow, green, blue, purple, black, white predefined for us, but they don't. So or at least if they do, I don't know it. But to define colors, you give the RGB value, which is red, green, blue. So for example, white would equal, and you can give it in a list or a tuple. I prefer to give it as a tuple. So white is going to be 255, 255, 255. And what this means is it's actually the 256th element of each spectrum of red, green, and blue. And conversely, black, as you might guess, is going to be 0, 0, 0. So let's talk real briefly about this. So first of all, this would be 256-bit color. So you've got 256 times 256 times 256 combinations of colors that you can choose from here. And also, what is RGB? Why do we use red, green, blue as opposed to red, yellow, blue as we were taught in school? Pretty soon we're going to see another thing that is kind of different compared to what you were taught in school, and that's coordinates. But here we use red, green, blue, and the reason why we use red, green, blue. The reason why we use red, green, blue in like computers and stuff is because computers have like a backlight, right? When you look at your screen, you have a backlight, and really some of the first monitors really did. There was like a true backlight, whereas now we have either LED and then there's all kinds of other fancy stuff going on. So we don't have to necessarily continue using RGB, but that's just what we got stuck with. And you've got basically two different types. So red, yellow, and blue. You can think of it this way: if you have like a piece of paper and you paint some green on there, and then you take that same brush and you brush another like stroke of green over the previous green. Is that green going to be darker or lighter? It's going to be darker. So the more color that you add in the red, yellow, blue kind of arena, the darker it's going to get. Whereas, so really black in our you know, red, yellow, blue is almost really a mixture of everything. And even though in reality by law, like white is actually a mixture of all colors. But anyway, that's aside. Anyway, if you were to mix all of your colors, you get a blackish color with paint. Whereas with when we consider light, for example, the absence of light is what? Black, obviously. And if we mix all of the light colors, what do we get? White. And that's how we actually are told in school as well, that white is a mixture of all of the colors, and this blows people's minds. Well, it's because the human eye sees colors based on lights, so that's why. But anyway, moving on, that's why we use RGB with computers. So that's black and white RGB. I'll show you guys a few other ones. Obviously, like for example, if this is red, green, blue, right? So we should be able to deduce that red would equal what? Well, 255.00, not 2005. 255.00. There's also an optional parameter usually, and that's alpha. and alpha is a degree of transparency. Actually, alpha I think is opaqueness. But anyway, more on that later. So now we've defined a few colors here. Let's actually go ahead and use these colors. So for example, the most basic way to draw something to the screen is by using fill. So right now when we run our game, up pops a purely black screen. So we don't have anything. We can clearly see the default is black. Well, we don't really want black, so let's go ahead and close out of that. And let's say we wanted a white background. Well, the way that we're going to generate a white background, so it is we're going to have to use fill, and we can see here that this is our while loop. So this is the loop that is currently functioning as our game loop. So basically, like you hear main loop a lot in games, we have a game loop. This is our game loop right here. This anything that's falling under a while. So we obviously don't want to put it in the event handling loop here, which is our for loop. That's our event handling loop. We actually really kind of want this in just in its own little right. So that's going to be here, and what we're going to do is we're going to say we're going to use fill, and fill is something you apply to a surface object. So what is our surface object? Well, if you recall, pygame.display.setMode returns a pygame.surface object. So that's what we're going to fill. So we would say game display dot fill, and here you can say what color you want to fill with. Well, let's say we want to fill white. So we'll save that and we can run that. And apparently, oh, I know what I did wrong. Okay, so it's a good opportunity to bring up updating and all that again as well. So keep in mind, like I was saying before, that what you do first is you draw everything in the background, and then once everything's drawn, then we render it. Because like I was saying before, rendering is what takes the most graphics, or rather the most processing power, is the actual showing of the graphics. So what's nice is in the background, we can generate it and say, okay, we want this here, this here, this here. And as you can imagine, say we've got a white background, and then we've got a snake and some apples. Well, that snake and some apples is covering over some of that background. So in theory, we don't necessarily generate that. But what if we were generating the whole background, then a snake, then some apples? There's some waste there. So anyway, so what we have to do is after we've done an action and we're completely done with all of the actions that we want to draw to our screen for that frame and that frames per second, then we have to do pygame.display.update, and that will update our display. Currently we still don't have frames per second. That is coming, but this will still work because it will work within our while loop anyways. So so let's go ahead and save and run that real quick. And now we have our white background. So that's how we can fill in and give ourselves a background. In the next video, I'm going to be talking about how we can actually draw like we can draw a smaller shape, and I'll actually blow your mind with fill, because most people actually use fill to totally fill the background. You don't have to do that, and actually fill is the superior choice because you can use accelerated graphics acceleration. But more on that in the next video, so stay tuned for that. Thanks for watching.